Hey guys, we are ready for section 7, lesson 3, and today we're going to be talking about similarity and transformations. Let's go back and review some stuff. We've already talked about congruence. In fact, we've talked about congruence a couple of times. Congruence meant that it was the same size, same shape. It was identical figures. Well, today we're not talking about congruence. Today we're talking about similarity. But similarity and congruence are very close to each other. Congruence means that they're exactly the same size, same shape. Similarity means that they're the same shape, different size, which means that they could be smaller, they could be larger. Okay? So now let's fill in this over here. Excuse me. We have heard all of these words in our last unit. So let's start with dilation. So it should be, I can't answer this for you. Okay, so you're going to have to answer these whether you know it well, whether you've seen or heard about it, but you don't really know what it means, or whether you have no clue. I can't answer those for you, but I can tell you what they mean. Dilation means when you make an image bigger or smaller. So every similar figure, every figure that's similar will have a dilation in it, okay? Every one of them. So all of our figures today will either be made bigger or smaller. We'll be doing a dilation. The scale factor is how much bigger or smaller. And then similar figures, we've already talked about what similarity means. Similar figures means that they're the same shape, different size. Okay, I'm actually going to skip over some of this stuff, and I'm going to go right over here to the next page. We're on page 538. And 538 has the actual definition of similar. Similar means that it's going to have a transformation. Remember, transformations are translations, reflections, rotations. So it's going to have one of those three things and a dilation. Similar figures all have a dilation, and then they may also have some of these other things, okay? So now I want you to go look right here on page 539. This is a very important chart for you. It says if your dilation is between 0 and 1, for instance, if it's 1/2 or 1/4, if it's between 0 and 1, that means that it's going to make the picture smaller. If it's equal to 0, it's going to be the same size. If it's greater than 0, like if it's going to be 3, 4, 7, anything bigger than 1, I'm sorry, I said 0, anything bigger than 1, it's going to make a bigger image, okay? So now let's go to page 540 because I think these examples are a little bit better written than the examples in your book. So let's look at this first one. It says, are they similar? Well, if I look at them, they kind of look similar, but I have to be able to prove that mathematically. So let's look at one side. For instance, let's look at side AD. Side AD is 2 boxes long. Okay? It is comparative to side EH. Those are the same sides of the same of the figures. So EH is 1, 2, 3 boxes long. So it's 2/3. My fraction for that comparison is 2/3. AD is 2 boxes, EH is 3 boxes. So now I have to look at a different one. Now I'm going to compare AB. AB is 1, 2, 3, 4, 5 boxes. And it's going to compare to EF. And EF is 1, 2, 3, 4, 5, 6, 7 boxes. Does 5/7 reduce to 2/3? Well, the answer is no, it does not. So if they do not reduce to the same number, then they are not similar. So the answer is no, they are not similar, even though they look similar. They are not similar because they do not reduce to the same fraction. Okay? Now let's look at number 2, and again, we're going to compare sides. So here's ED. So I'm going to compare ED, and ED is 1, 2, 3 long. And if I look at that, well, ED is on the side of the right angle, so it's going to be compared to BA. And BA is 1, 2, 3, 4, 5, 6. So that's 3, 6. 3, 6 reduces to 1/2. So now I want to compare that to another side. So I already have 1/2. That's one of my side lengths. Now I want to compare a second one. So I'm going to compare EF. EF is 1, 2, 3. And I'm going to compare that to CB. CB is 1, 2, 3, 4, 5, 6, which again reduces to 1/2. So because those are identical, yes, and I went from this small one to this bigger one, or you can go from the bigger one to the small one, but either way it has a dilation factor or a scale factor of 1/2, because that's what I got when I reduced my fractions. Okay? All right, let's look down here. We're going to read number 3. We're talking about a t-shirt iron-on. It measures 2 by 1, so it's 2 inches by 1 inch. Okay? And it's enlarged to a scale factor of 3. So now remember, anytime I have scale factor, I'm going to take each of these times my scale factor. And my scale factor right here was 3. So I'm going to take this times 3, and I'm going to take this times 3. And it says the second iron-on is enlarged by a scale factor of 2 for the front of the shirt. So the back of the shirt, it says the second iron-on. Okay, hold on. It is enlarged by a scale factor of 3 for the back of the shirt. So this is for the back of the shirt. For the front, it's that same logo. It's 2 by 1. But now it's enlarged by a scale factor of 2. Okay. Are they similar? Well, let's look. What are the dimensions of the largest iron-on? Well, the dimensions of the largest iron-on is times 3. So it's 2 times 3 is 6. 3 times 1 is 3. So the dimensions of the large iron-on is now 6 inches by 3 inches. And it says, are they similar to the original? Well, the original was a 2 by 1. That's what it told us. The original one was 2 inches by 1 inch. So now I have to see if they're similar. Well, this one, we already said is 6 by 3. Does that reduce to 2 over 1? The largest one is 6 by 3. Does that reduce to 2 over 1? Yes, it does. So far this one is similar. Now I have to look at this one. 2 by 2 times 2 is 4. 1 times 2 is 2. So my second one is a 4 by 2. Does that reduce to 2 over 1? Yes, it does. So my second one is also similar. So my largest one measures 6 inches by 3 inches. And yes, they are similar. And if I asked you why they were similar, it's because the first one, when I took them both times 3, I got 6 over 3. The second one, when I took them both times 2, I got 4 over 2, and both of those reduced to 2 over 1, which was the same as my original. All right, guys, if you have any questions, please make sure that you come ask us what those questions are. Make your notes off to the side somewhere. In fact, there's some space down in here that you can make your notes on, and we will try to answer those. We will answer those for you tomorrow in class. Have a great night. Bye.